Okay, ready for your last example in chapter 6.2. I hope that you're starting to get the gist of what's happening here in this section. If you don't, then email me and let me know. So here's the last example that we're going to do. We're on page 278. Yes, page 278, number 12. Alrighty, and we're going to look at these two equations and we want to solve for these two equations by using substitution. Now let's see if you can do better than the on-site kids, my online students. Good to see you again today. Right, so we're going to see, okay, we want to substitute. Now we've learned about substituting. And the two previous examples that I showed you was easy because either the x or the y was already isolated on its own. But now we see none of these two are. Okay, because there's a 2 in front of the y and there's a 2x in front of this y here. So it really doesn't matter which of the two I pick. I can pick either one of the two and change it so that I have y on its own in order to substitute into the other equation. So to me it seems like the easiest one would be the second one. Okay, where I can go and now divide by 2 right through in order to get y on its own by itself. Okay, so here we go, we have y is equal to 5 minus 2x. Okay, so now we get to the substituting part. This is the substituting part where I substitute whatever the value of y is here into the value of y there. So this whole thingy that I have here is going to go into y's place over there. Okay, that is just substitution for you. So I'm going to put it in there. Let's write the second one. 2x plus, now instead of y, here goes y. Instead of y, I have 5 minus 2x is equal to 5. Alrighty? Now we can see that again something weird is happening because 2x minus 2x gives me 0. So what am I ending up with? Oh right, 5 is equal to 5. Now if you can remember back from what we did in section 1, when we get it to a situation like this, that means that it's an identity. And it means that these two equations are basically the same thing. They're basically the same equation. Okay? And that would then tell us if you get to this end here and whatever is on the left is equal to whatever is on the right, like in this situation 5 is equal to 5, then it tells us that we have an equation. These two equations are actually the same, okay? And when they're the same, it means that we have a infinitely many solutions. So in this case, I would say infinitely many solutions. And I know that you might be a little bit confused, so I'm going to show it to you in a different way as well, so you can see why we can say infinitely many solutions. Okay, let's just go back to this equation. 2x plus y is equal to 5. Right, let's rewrite this equation into slope-intercept form. I'm going to move over here a little bit and I'm going to say, okay, 2x plus y is equal to 5. Let's rewrite it in slope-intercept form. Y is equal to minus 2x plus 5. That's equation 1. Now let's do this one in slope-intercept form. Okay? We already did the dividing here. So that one would be, let's do it from the beginning. 2y is equal to 10 minus 4x. Okay, you've got to divide by 2 to get it into slope-intercept form. So y is equal to minus 2x plus 5. I just rewrote them in the right form. What do we see here? We see that here is the first equation, there is the second equation. It is the same situation as what we had in the first section, where they are basically the same line, which means they're going to lie on top of each other, and every point on the line is a solution for that line. So how many solutions do we have? Infinitely many solutions. We just proved it in two different ways. We rewrote it into slope-intercept form, and we did it by doing substitution. Now I understand that students find this a little bit easier than this. When we get to the test, you'll be able to have a choice whether you want to use substitution or just something as simple as this. Alright, thanks guys, see you again.